Section 3, and we're going to be talking about solutions and management tools. And this whole section 3 is about 10 to 15% of the test. So you really do kind of just want to understand how Azure provides solutions and management tools for you to actually operate cleanly in their cloud. And one of the first ones they talk about are IoT Hub, Iot Central, and Azure Sphere. So Internet of Things is really big, especially if you're pulling in telemetry data or you're pulling in data from multiple resources, manufacturing, power, anything that has control units, anything that has anything like that, where there's a lot of data generated, and you need to have a strategy for how you're going to manage all that data across all of the systems that are talking to it. So IoT operators are going to get a bunch of tools in the Hub, Central, and Azure Sphere. So the IoT Hub is basically the features and a model that allows device and backend developers to build out management solutions for devices. And that includes sensors, microcontrollers, gateways, and other things that go along with that process. So IoT Hub, backend developers building robust device management, mostly on microcontrollers and sensors. That's the big thing to remember here. And then you get into Iot Central, a managed application platform that you can use to create custom IoT solutions. So a little bit different than what you see in the Hub, right? There's a bunch of templates you can use. There's specific industries such as energy, healthcare, and government. Iot Central application templates allow you to deploy an Iot Central application and then customize it later on. So with that Iot Central, you've already got all your stuff deployed and you're bringing in data. And now I'm going to use Iot Central to build my themes, my dashboards, and my views, which is different than what you get in Hub. Remember, Hub is more generalized to your developer working with sensors and microcontrollers. Iot Central is more about creating your dashboards and your views into the data. And then finally, there's Azure Sphere. It's a high-level application platform. It has all the communication and security features for internet-connected devices, and that can be things like your thermostat, your microcontroller units, your sensors, and anything else that you can connect to this in that IoT bit. Right? There's custom high-level Linux-based operating system and cloud-based security service, so you can actually keep track of the security of all your things. Azure Sphere includes security as part of the basic thing. So that's the big thing to remember, right? And then Azure Sphere security is really a big part of this whole thing. And that's where you kind of want to take a look at how your microcontrollers, your sensors, your data sources, your manufacturing processes, anything else you've got going on can securely connect with the cloud and the web. What makes this interesting, though, is that they can actually push down patches if you need to deploy devices to mitigate security. So that's what makes this really interesting, is that you can push down patches to your microcontrollers or your sensors without having any end user intervention. So you can close this common security hole, and it's been a big security hole in manufacturing and IoT sensors and command and control systems, microcontrollers. So if you don't have that already, if you're not used to that or you're not comfortable with the idea of that, Azure Sphere can be a really big part of making your company a whole lot more secure at the microcontroller and at the sensor level. But you're going to need to start making some policies around that. So the big thing, honestly, on this one is just to remember that Azure Sphere has an integrated security section in it that will actually allow you to push down patches and updates to specific sensors and other things. And it can be really kind of interesting. So the Azure Sphere MCU alongside or in place of existing MCUs really gives you more security, productivity, and opportunity, right? Allows you to secure the application environment, make sure that all your connections are authenticated, opt-in use of peripherals, just a whole ton of stuff, right? Because we do have denial of service attacks, we do have rogue software, we do have ransomware now. So that can be, this can be one way of solving that problem. We all don't want to be Colonial Pipeline here, right? Software updates can be automatically deployed from the cloud to any connected device to fix problems, new functionality. So this can be a big part of your CI/CD pipeline. And then product usage data can be reported. So again, a little bit more in depth. This is much more your management, security, management, and control. So your IoT Hub is for developers. Your IoT Hub is for developers. Your Iot Central is for your dashboards and everything else. And your Azure Sphere is really for management of the whole kit. Everything you're doing in IoT will work underneath that. So in summary, though, you just need to remember that there are 3 IoT supported systems: Central for developers, IoT Hub for your dashboards, and your Azure Sphere for actual security and support for specific devices along the way. And that's really all there is to IoT. I know IoT is a much bigger industry than this would give you belief in. But again, for this test, it's just enough to know what they are and how they work. All right. Thank you for starting off with section 3 with us, and I will see you in the next lecture. Okay, so this is section 3.2, analytics for your AZ-900. So analytics is really becoming a backbone of what we do here. And there are 3 analytics services that you really do need to be aware of. One of those is called Synapse, the other one is HD Insight, and the other one is Databricks. So as you go through your analytics package, and Azure Synapse is an enterprise level analytics service. And basically this is your data warehouses, your big data systems, your data lakes, all those things that you would be looking at to build out your dashboards, right? Azure Synapse brings together SQL technologies to work on this, as well as Spark technologies used for big data, Data Explorer for log and time series analytics, pipelines for data integration, ETL and ELT, deep integration, such as Power BI, Cosmos DB, and Azure Machine Learning. So Azure Synapse is really that analytics service. It's the whole big package. It's everything that you would need to know about where you're going with your data. And if you're doing data lakes, and you're doing big data warehouse processes for working out on your company's data, then this is where you want to be in Azure Synapse. So Synapse SQL, though, is the distributed query system of TSQL for data warehousing. So it has its own kind of language that goes along with it. So when you write queries, when you ask questions of the data, you're going to use Synapse SQL. It looks just like regular SQL. It's just a little bit more streamlined on the end and actually addresses some machine learning scenarios about the data that you aren't going to find in regular SQL. So again, there's serverless and dedicated resource models. Again, you're going to see a lot more serverless technologies as it happens. The serverless works for unplanned or bursty workloads. It's always available. And you have an SQL endpoint for that as well. So remember that there is its own Synapse SQL that is more geared towards data lakes, streaming, and machine learning scenarios. There's a lot of built-in streaming capabilities already, so you can already pick and choose to see if someone's already made something. It's interesting too, you can also integrate that SQL query and go into a predict function with Azure AI for machine learning models to score the data. So that's kind of a neat addition to the language. Then there's Azure HD Insight. Azure HD Insight managed full spectrum open source analytics package. You can use open source frameworks such as Hadoop, Spark, Hive, LLAP, Kafka, Apache Storm, and just keeps a long list going. So again, it's a cloud distribution of Hadoop components. So basically you're going to be working on data reduction, data processes along that line and try to figure out how your data actually works. It's a cost-effective process to just use a lot of amount of data. So you can use this in conjunction with your data lake. You can use ETL to transform and load data warehousing, machine learning, and IoT. This is one of the neat things about HD Insight is that you can actually bring in and use this as a separate dashboard for your IoT functions outside of Azure Sphere or IoT Hub or IoT Central. Right? So Azure HD Insight can be used for a lot of scenarios in big data processing, be it historical or real time. It's essentially more of a jack of all trades kind of process here for data analytics. And then there's Databricks. Databricks is actually really kind of interesting because you have 3 environments basically depending on what you want to do. There's Databricks SQL, Databricks Science and Engineering, and then Databricks Machine Learning. And each of these has got different skill sets that you're going to need to work with that will either make your life a little bit easier or a little bit harder as you go through and using Databricks. So Databricks SQL, right? And that's how you're going to ask questions of the data that you've got. An easy to use platform for analysts, right? So this is based on analysts to just want to see what their data looks like on their data lake. You can create visualization types, explore query results, different perspectives, and you can build and share these dashboards. So this is really more for your analysts, Databricks SQL. Then there's Science and Engineering. Now, Science and Engineering, though, is a lot more intense because you're going to want to have data engineers, data scientists, and machine learning engineers. So science and engineering is more for your people that have an analytics background, that have degrees in this, data engineers, machine learning engineers, people that understand how machine learning and AI works. So this isn't for you or me. This is really more for your science team to use. And they can work through all of the data that's either in your warehouse, in a data factory, stream data, Apache Kafka, IoT Hub, all of this stuff. It can land in your data lake. It can be blob, it can be files, it can be notes, it can be log systems, it can be anything. And then let your engineers go and let them build something really, really super cool and drop it into a dashboard for you. But the thing about Databricks science and engineering is the big thing is to remember, you need people that are trained to use that kind of software, that kind of process. And then finally, machine learning. This is also another one where you're probably going to want to have a team of people that understand how machine learning actually works, to kind of make it a little bit easier on you, because even just making sure the data is clean in machine learning can be painful. So Databricks machine learning is basically an integrated end-to-end machine learning environment. You can bring in your data, you can train, you can track your modeling, you can see if there's a future development and see how well it predicted the future, and then go ahead and do model serving from that through other dashboards. So you can break this data down and move it into something else for later on. So Databricks, machine learning is probably where you're going to want to have more of your talent and people going. So general terms, remember those general terms, right? And then know the 3 kinds of analytics package. Azure Synapse, which is more for everybody, right? That's anyone that knows how to use SQL can use Synapse. HD Insight, same kind of thing. And then Azure Databricks, depending on what skill level you've got in your company, is where they're basically going to kind of break out and how that will all work to help you get to where you need to go. So that's it for analytics and analytics packages. So do let me know if you've got any questions, and I will see you in the next lecture. Under section 3.3, cognitive services. So this is probably one of my favorite sections of the whole thing, because we're talking about machine learning. We're talking about how to program a computer to answer questions or behave like a human being, or do chat bots, or do any of those other things that we would do to kind of ease the load on people. So Azure Machine Learning is basically part of cognitive services, and it's a cloud service for accelerating the machine learning project lifestyle. And you're going to see a new word in here, MLOps. MLOps or MLOps. It's a set of practices to deploy and maintain machine learning models in production and reliability and efficiently, right? There's a compound of machine learning and DevOps. So MLOps, depending on how your person says it, you bet you there's going to be all sorts of interpretations of that word. That's the new word for the day. It's the word to remember, right? And that's part of Azure Machine Learning. So this is what makes this really kind of neat, is that once you create a model in machine learning, regardless of what data you used, whether it came from a data lake, a data analytics package that we talked about earlier, or something else like that, you actually can really build some neat things that can come out of this. And you're going to use open source platforms. So you can use PyTorch, TensorFlow, Skitlearn, or anything else, and help you monitor, retrain, and redeploy models as you get more data in, right? A model isn't a fixed thing. That model under MLOps is basically something you're going to be constantly updating and reevaluating by using machine learning tools. So Azure Machine Learning is for individuals and teams implementing MLOps within their organization to bring machine learning models into production. Right? So that's the big one, security, auditable, production environment. So machine learning as well means you need to have a data analytics scientists and ML programmers. So this is not for just regular old people. This is for people that really have deep knowledge on how data analytics, your PhD scientists and machine learning programmers will work with this product more than anybody else. So Azure Cognitive Services itself, they're all cloud-based services. So they're all managed with REST APIs, client libraries available to help you build these applications. You can add features to your applications without having data science or data analytics skills by actually using already existing models, already existing systems that will work. And Azure Cognitive Services comprises a bunch of that will allow you to use basically public or open source data models to kind of help you out. And those models can help see, hear, speak, understand, and even make some limited decisions at this point. So we're kind of moving along there. So the catalog of cognitive services are vision, speech, language, decision, and search. And those are the big ones to remember. This is the big slide here that you want to remember for all the things that you've got going on here. So with Azure Cognitive Services, you have access to development options, right, beyond what you need for your data scientists. This is more for us, regular people. Automation and integration tools, logic apps, automation systems, deployment options such as Azure Functions. And again, we get back into that serverless environment. It's going to become really, really big and function as a service, as the app service. Cognitive services can also include Docker containers for secure access, so you can actually break things down into a little bit more of atomic level at the Docker level by using functions along the way in Azure Functions. Tools like Apache Spark, Databricks, Synapse, Kubernetes service, all these things tie together to give you that cognitive service, the one that you're going to use for your system. And there are some of them, right? So is your bot service. This is actually really kind of neat because, we all early on did bots. I don't know if anyone remembers any of the simple bots that we had back in about 20 years ago. And it's grown since then. So right now the bot framework includes a modular and extensible SDK for building bots. And you can use for speech, chat, you can use these to help route service desk questions and other things along the way. So the bots have come a long way from over the last 20 years. They use speech, they can understand natural language, and they can understand questions and answers and do more than just what they were able to do before. So it's a neat thing to have this service, especially if you need a chat bot or you need a help desk service routing bot or you need something else like this. This kind of gives you that added little chunk of functionality for your website or for your application, right? So bots can provide an experience that feels less like using a computer and more like dealing with a person, and that's huge for customer service, right? They can be used repetitive tasks such as taking dinner reservations. That's how OpenTable kind of works, gathering profile information, and then automated systems. And some of the stuff may no longer require human work at all. Right? So users converse with a bot using text, cards, and speech. A bot interaction can be quick to answer that question, or it can be sophisticated conversation that you can provide access to services. So the Azure Bot service is actually probably the one you're going to interface with the most because it's the most flexible. It's the one that's the easiest to implement. Right? So a bot can be thought of as a web application that has a conversational interface. So you can connect to that bot through Facebook, Slack, Teams, whatever. The bot will reason about that input, perform the task, or ask for additional information if it needs it. The bot performs recognition on the user's input to interpret what the user is saying, so it can go back and ask for clarification. The bot generates responses to the user communication so that the bot can say, hey, I'm done doing this. Or depending on how the bot is configured and how it's registered, users can interact with the bot through text or speech, and the conversation might also include images or video. So that's kind of a neat thing. I haven't seen a video bot yet or an image bot yet, so I'm kind of hoping that maybe I'll stumble across one. But it is kind of neat that the bot service, again, is the most flexible of the lots. So bots can do the same things other kinds of software can do: read, write, use databases, APIs, regular tasks that we do every day. But what makes them unique is that basically the mechanisms are a step up. And the things that used to be human-to-human communication can now be bot-to-human communication. So that's the big thing to remember about the bot service, is that it's really more for us. It's really about the things we do. So that Azure cognitive services are the future. This is where we're going. And that's the big thing to go back on this one. Right? Remember the type and basics of each cognitive service as you go through the test. And then most pre-tests have at least one or two questions about cognitive services. And that's kind of the interesting part. It's usually been limited on what kind of vision or what does this bot do. So it's nothing like super detailed. It's not going to ask you how to program it. It's going to go, what does a vision bot do? And that's going to be one that works on working with pictures or being able to see environments. All right, and that's it for bots. That's it for section 3.3 in cognition. And I want to thank you very much for being here, and I will see you in the next lecture. This is section 3.4, and this is the AZ-900 serverless version of it. And again, we keep on seeing this pop up throughout the exam, so this is going to be a larger section, I think, in terms of things that we need to know. So Azure actually has a serverless system, and those are basis of cloud native programming. And that's the big one. Anything that's serverless is cloud native. You're taking your program, you're breaking it into smaller chunks, and you're putting those chunks either a container, a function as a service, and basically enables developers to build applications faster by eliminating the need for them to interact with or manage the infrastructure. So that's a big one. Serverless applications, a cloud server provider will automatically provision, scale, and manage the infrastructure required for the code. So that's where you want to look at that one, right? Is that serverless system, again, allows developments and developers to move faster. So the serverless model comes from the fact that tasks associated with infrastructure provisioning and management are invisible to the developer. So this is really developer centric, right? Your administrator, your security, and your other folks are going to be looking at that infrastructure, but from the development viewpoint, it's a code set. That's all they're doing. This approach enables developers to increase their focus on the business logic and deliver more value to the core of the business rather than trying to go back and figure out how to make something work on Linux or make something work on Windows, right? Serverless computing helps teams increase their productivity and bring products to market quicker. And again, allows you to better optimize your resources, stay focused, stay on track, and understand that innovation is kind of an interesting thing. You just have to also be careful that you don't break stuff, right? So a serverless approach offers developers, teams, and organizations a whole new level of abstraction that enables them to minimize time and resources and infrastructure management from the developer viewpoint. Every component of an application benefits, right? Because now you can just take a look at that component and see how it interacts. And those interactions can be between databases, analytics, messaging, AI, machine learning. So that's the neat part about it. You're basically building connectors and glue to do a thing for whatever application you're running. And then you can just turn this into an end-to-end serverless platform that from the time the customer does a thing to the time the customer is done or the project is delivered, you've basically managed this as a cloud native process where each step of the way is solved as part of a business logic or part of a customer flow through your systems. And that will make a lot more benefit. If you find a choke point, you find a place where people are hitching up, then that's exactly what you're going to go fix in the business logic or the customer flow through the system. So Azure Functions is a serverless solution that allows you to write less code. And again, we're function as a service. So we're kind of back there again. Instead of worrying about deploying and maintaining servers, your cloud infrastructure is just what you need to keep your applications running, and no more and no less. It's also super inexpensive when you do it that way. So Azure Functions as a service is basically what you're going to be working on as a web API, database changes, processing IoT data streams. So it's essentially pulling stuff out and taking a look at them through the message queue or through the actual stream of data. Azure Functions allows you to implement your system's logic into blocks of code, and these blocks of code are called functions. Again, function as a service. So different functions can run anytime you need them to. You'll also hear function to zero, which is basically only run them when necessary. There's some days you won't need to run that function at all. So Azure Functions meets the demand of scaling and elasticity as you kind of go through this process, because it will just go ahead and add extra resources as you need them. And then finally, Logic Apps, cloud-based platform for creating and running automated workflows. That just basically is an automated workflow. It's going to integrate with all your stuff, your data, services, systems, applications. And then on that platform, Logic Apps, you can basically build your B2B scenarios, right? Or your B2C, your customer, your business-to-business bits, and make sure that you have an adequate workflow for customer product delivery or management or anything else that you've got. As a member of Azure Integration Services, Logic Apps simplifies the way that you can connect legacy, modern, and cutting-edge systems. Right, so if you connect this to your data center using a VPN or using some form of peering or express route, then this is one way of getting your business logic into your data center and into the cloud so you can do things with it. So just a few example tasks kind of help you out on this understanding how Azure Logic Apps works. So from the book, they basically say that Logic App Service will schedule and send email notifications using Office 365 when something happens, right? New file is uploaded, someone needs to see it. It can send a request to the person who uploaded it, hey, can you give me access? Route and process customer orders across on-premise systems and cloud systems. Move uploaded files from secure file transfer or FTP to Azure storage, which is kind of neat, right? As you upload things, you can also manipulate those along the way. So you see this a lot with imagery systems, that someone uploads a file for their Flickr or for their SmugMug or for their Facebook or whatever, and then there's a process in the back end as they move it over to storage to resize or reformat that image so it looks a little bit cleaner. You can monitor tweets, and this is actually part of a big machine learning and data customer sentiment about your company in terms of how do you train that model. Well, you can use Logic Apps to analyze tweets and analyze sentiment across Facebook and other interconnected apps to create alerts or tasks for items that need to be reviewed. So like, let's say all of a sudden you get this cluster of really negative reviews in the Midwest, right? For whatever reason, you can spot that earlier by using Logic Apps, especially if you're connected through the data feeds on social media, and then go figure out what's going on and maybe do an earlier intervention on something that would have otherwise been invisible in the past. So it's kind of a neat thing that you can do on that whole process. So in summary though, serverless is really the way we're going to program for the future. And you're seeing a lot more of Azure and indeed everybody at the same time, moving things over to function as a service or logic services and treating each step of code as part of the business process, part of the business workflow, or part of the business logic. So just be really familiar with what these services are, and then that's all you really need to know for the test. You don't need to know much more than the name and what they basically do. So that is it for serverless and serverless systems. And I really want to thank you for being here, and I will see you in the next lecture. So this is AZ-900, this is section 3.5, and this is for DevOps, development operations. This is kind of a lengthy section. There's a lot to this, so kind of just sit back, pop some popcorn, and listen to what we got cooking here. So DevOps is basically a generic term for continuous integration and continuous development or continuous deployment, depending on who you listen to for what CI/CD actually means. And it's basically an effective way of just making updates to operational code. And that's all it is. DevOps is a compound development and operations, so DevOps, and it's basically people, process, and technology to continually be updating code so you can be providing more value to customers as you go through your day. So DevOps influences the application lifecycle throughout the entire process: plan, develop, deliver, and operate. Each phase relies on the other, but each phase is not role specific. You can have developers and QA in there at any time. You can even have customers in there as part of the planning process if you've got something specific that you're building for a specific customer. And true DevOps culture, each role is involved, so you want to make sure that you've got that kind of represented as you go through this whole process of learning what DevOps is. So you just need to know what the 4 phases of DevOps are. You don't need to really understand much more than that for the exam. And that's basically plan, develop, deliver, and operate. You're going to plan your product, you're going to develop your product, you're going to deliver your product, and then you're going to operate your product. And you will be continually doing this. The project will never die, it will never end. But this is a good way of handling this in a project management style. So DevOps has actually got some really good project management step-throughs on this one. So the one thing you do need to know for the exam is what this is made of. So Azure DevOps is made up of multiple products, right? Not just one, but it's all underneath one big umbrella called Azure DevOps. So you've got your CI/CD pipeline, you've got Azure boards, you've got Azure repros, test plans, and artifacts. So those are really just what you need to know. You need to know when you'd also use them. So Azure CI/CD pipeline is just basically how you plan and execute the process to build and test code projects. That's really all there is to this. Azure pipeline combines all the CI/CD process that you would ever want to test and build your code and ship it to any target, right? So that includes your Docker, your Kubernetes, your VMs, to your function as a service. You can do this however you want to do this. Continuous integration is where you're basically working with a development team and keeping track of bugs, keeping track of new functionality, build, test, deploy. Continuous delivery is that you're constantly deploying all those new things to make sure that your code is meeting the standards or practices or business logic or anything else it needs to meet on a regular basis. And then testing is another part of this continuous testing, which is kind of on the side of this. You want to make sure that whatever you build is safe, make sure whatever you build actually works and doesn't cause more problems for the customer than it's worth. So you do want to incorporate continuous testing as part of this, whether it's in cloud or whether it's on-premise, and there's some neat things that you can do inside of Azure when you're built to test your workflows to kind of help you figure out if there's a testing issue and then throw that back into the CI/CD pipeline. So Azure CI/CD, you can use any any code that you want, and works with most application types: Java, JavaScript, Python, .NET, PHP, Xcode. So that's the neat part about it. You're not just limited to one language. You have Azure DevOps, a number of tasks that you can use and build and test your application. Then you can use pipelines to deploy your code to multiple targets. So you've got something that runs in Kubernetes, you've got something that runs in a VM, you need a little bit of disk space, you need some persistent storage as part of a network attached storage. You can go ahead and do all of that to deploy your code to multiple targets. And that's the neat part. You can do this as any kind of environment that you want. You can also publish your mobile application to a specific store. And that's another neat thing about it. And once you've got this in place, then you just set your release pattern, how you want to go ahead and set up deployment of your application into one or more environments. And then you set up again, you rinse, recycle, and repeat. That automation process is a collection of tasks that you go back through, and you're just checking it again. You want to make sure this meets your business logic. You want to make sure this meets your workflow. You want to make sure you're not causing your customers any extra friction points because the code is buggy, all that kind of good stuff. Azure Boards is kind of a neat thing. It's a web service. And this is how you can manage your software projects. It's a rich set of cool capabilities. For anyone that's familiar with Scrum or Agile or Kanban boards, you just make some really neat dashboards. These are great for managers. This is great for your project manager, and really, really, really easy to keep track of where your project is. So Azure Boards is basically your program management interface into how do you keep track of what your program and your code is going and how your people are working and any hitches that you may got, right? You can track work products, you can track the entire workflow, you can do task features, bugs, all the things that you would normally find. Azure Boards is your dashboard. And that's really what you need to remember on that one for that whole process. Git and GitHub, this is basically your version control. So if I've already done a code program, I did it as a function, I uploaded that function and it works, and someone else comes along and says, oh, it would be really cool if we did this with that function as well. They could pull down my function, make those changes, and it would be uploaded as version 2 or version 1.111 or whatever version system that you use in terms of numbering and capability. The cool part about Git and GitHub is that you can work offline or remotely. You can work on or offline. You can work in any environment. You can be sitting in Starbucks working on your code, or you can be sitting in your living room or in an office. Developers can commit their work locally, but it does require a sync back to the server. But they can check in locally, so they can actually finish something locally and then wait for the sync or move on to another project if they've already downloaded the entire repository to their system. So do be aware that you might get collisions, but that's relatively rare, especially if you're using really good project management on this. So it differs from the centralized version control we're really used to, where you go in, you download that specific chunk of code, it's logged out to you, and then you have to upload your changes in your code before you can do anything else. This paradigm for GitHub, especially with local offline, you can just basically be synchronizing your code all the time and just keep on going. That's the neat part about how Git and GitHub actually works. Github Actions is the automation software within Azure to help you do exactly that. Right, so you can actually use software development workflows, and that's the big part of this. You can deploy the workflows in the same place where you store code and then collaborate on pull requests and issues, especially as you tie them with your boards. So that workflow can be your workforce logic, it can be your business logic, it can be a product, a service, anything that you've got going. Those workflows are really how does your code or how does the customer move through your code, and then you can test, package, release, and deploy within that workflow. So the workflow is basically the how does the code work and how does my customer interact with that in comparison to the business logic that I need to do. And again, each workflow, each step is made up of that individual action that runs. So like say I want this product, I put it in my shopping cart, that is one step in the workflow. Being able to search for the product is another step, and so on. So GitHub Actions is really neat, especially for Azure, so you can create those workflows for your customer, your business logic, and then build, test, package, release, deploy, boom, done, out of here. You can use all of your Azure services like App Service, Azure Functions, and keep on seeing functions show up right in this particular version of the test as your key vault, so you can use crypto instead of embedding your username and password into the code, which you never want. So again, just neat things. You can do this as a resource manager template. You can work a command line. You can enforce policy as you go through, who can actually run that code or who can interact with that code. So again, just neat things on how GitHub Actions for Azure actually works. It gives you a bigger picture of what you can actually do with that code and how that code works and what services it interacts with. Devtest Labs is probably the coolest part of everything that they've got in here for DevOps. So Devtest Labs is a service that basically enables the developer to self-manage all their virtual machines without waiting for anyone to approve it. They basically can build their own test environment and run. Go with it. They don't have to wait for the system administrators to build a thing. They don't have to worry about trying to find space or time in the test lab. They just build their test lab and go. So these are all pre-configured. They can be pre-configured using the Azure Resource Manager. These can be tied to a specific person. They can be tied to a specific department. And everything that the developer needs is there, especially if you're using Resource Manager templates. So Devtest Labs, right? You can just keep on testing your latest version. So let's say you make a tweak to the business logic and you want to test it out. Boom. Pop up your test lab and go. You can do this in Windows, Linux environments. You can do this in Docker, Kubernetes, whatever your environment. You can integrate this whole test process into your deployment pipeline. And you can also do some scaling, right? So you can actually test under load, which is neat because that's a really, really, really important part of the test that often gets overlooked. Devtest Labs makes it also easier to control the costs. So you can actually set policies on the lab, such as the number of VMs per user or per lab. So if you have just a regular developer, he only needs 1 or 2 VMs, but you've got a stress test lab that wants to do something else, scale, then you can do different policies by different resource templates. You can create policies to automatically shut down and start VMs. So if you press commit and you want to go straight to test, you can actually set that up to go. Or let's say you walk away and there's no action on that lab for 2 hours, you can get it to automatically shut down to save yourself some money. This is a great way of tracking costs as well for any kind of resources that are spun up in the lab to stay within your budget. If you set a research budget or a lab budget of X dollars, you can just keep on receiving notices on every time they burn to 20%, 40, 60, 80, 90, 95. So you can keep track of all those costs and you can take any necessary actions that you need to. The other thing that's nice about this is that you stay within the context of your labs. You're not in anything like a production environment or anything else. You're just spinning up internal resources for those labs. You're not doing anything other than that. So there's no way to really crash a production environment by doing Devtest Labs. So again, really neat. Lets you create your pre-provisioned environments to develop and test applications. That's exactly what Devtest Labs is for. And it's a neat thing to actually have, especially if you're a code developer. Or if you're a manager, you're not going to be hung up waiting for someone to spin up a lab. Your developer can just go straight there and do it. The other thing that's kind of neat too is your test plans. So you can actually go ahead and make a test plan in this environment, so you can test how that logic actually works. And then just basically browser-based test management. Everything is done for planned manual testing, user acceptance testing, gathering feedback, all those other things. You can do this within inside of test plans. So test plans is just kind of neat. That allows you to just basically do manual and exploratory testing on your code, right? So as your test plans helps you to automate planned manual testing, user acceptance testing, exploratory testing, and stakeholder feedback. So again, all the kinds of testing that you would do, especially if you're working through a business logic or a business workflow as part of this, that test plan can help make sure that your QA department is doing all the things it needs to do, or you can actually agree on what that test harness is going to look like as you go through and you test your code as you step through each section of the user logic to make sure it works in exactly the fashion that you expect it to do, and then throw it out onto the users, see if they actually like it. That's the neat part. You can actually create a smaller environment for acceptance process to make sure that users will actually like it and that it meets customer requirements. You can actually keep those kind of things moving so customers can go back and check the status of their project, especially if you're working as a third-party code developer. So neat stuff on this one. Azure Repros, this is part of the version control system that you've got with Git and GitHub. It's just basically a version control software that helps you track changes. It syncs into your Git, your GitHub, or your other anything that you've got that basically is your code repository. This is just a way of managing it. So that's all Azure Repros is. It's just another version control tool that you can use to manage your code. You can use Repros directly, or you can sync it with any other tool that you've got for managing version control. This one's like really super easy. With Azure Repros, again, you can type into Teams, you can type into Git, you can type into any other kind of version control you want, centralized or distributed. It's just, again, just another tool for managing your code and making sure of what you've got cooking. Then finally, we have Azure Artifacts. So Azure Artifacts enables developers to share and consume packages from different feeds and public registries. Right, so this is one of the big things, is that sometimes you have dependencies, sometimes they'll go and they'll change the libraries, they'll deprecate or make new functions and new services that are available to your developers. Artifacts helps keep track of all of that for you. And you can do it within the team, you can do it within the organization, or you can even do it publicly. So Azure Artifact gets built on a consumption basis. And basically it's free up to 2 gigs of storage, and you'll probably go over that depending on what your dependencies look like and what other packages you need to make sure of what's working, right? So if PHP comes up with some new thing and you really need to use those new packages, or you want to test it, Azure Artifacts is just a neat way of doing it. It's all pre-installed with Azure DevOps Services, DevOps Server, and TFS, Team Foundation. So it's a neat thing. It's just one of those things you've got just to keep track of how much storage you use, and just keep track of your packages for you, and keep track of any systematic updates that the developers or the process owners are using, especially when it comes to code sets. So in summary, this is a big section, right? But in reality, it just boils down to a couple of things. You just need to know what CI/CD pipeline are, Azure boards with agile planning, Azure repros, test plans, and artifacts are all about. Once you know what these things are all about, then you know when you'll use them. But this is really geared more towards the developer side of the house. All the pre-tests and all the practice tests I've seen so far don't really focus on this as much as this section does. But I want to make sure that when you're doing this, that you really do understand there's an entire environment for DevOps. And it's not small. It's a big part of what the cloud is all about and making things cloud native. So just remember what CI/CD pipeline is, as your boards, as your repros, test plans, and artifacts are all about. And you should be good to go. Thanks. I'll see you in the next section. 3.6, and we're going to talk a little bit about the Azure Portal, Azure Powershell, command line interface, Cloud Shell, and the Azure mobile app. So this is all just a bunch of services. And again, like most of this test, you just kind of need to know what they are and when you use them. So again, this section 3, really does throw a lot of apps at you. So the Azure Portal, that's where you're going to go. We've had a portal walkthrough. There's a portal walkthrough after this if you want to go check it out. But this is where most people are going to start off with Azure. You're going to walk through the Azure Portal after this lecture so you can kind of see what it all looks like. But again, for most needs, for most people, this is where you're going to go. This is where you're going to start up all your services. This is where you're going to see all your reports and all your dashboards and everything else. Other people will use other ways of doing things, but the Azure Portal, again, it's the web-based unified console. It's everywhere. It's portal.azure.com. And again, you just can do this to manage your Azure subscription. It's all graphical. And again, you can use this to build, manage, and monitor everything that you got running in the cloud. You can create custom dashboards as well, and that's the good part. So you can create custom dashboards for your developers, you can create custom dashboards for your business units, you can create custom dashboards for your financial folks. And again, then you just configure the accessibility, and everyone gets their view into the company cloud. So Azure Portal, again, is designed for resiliency. It's everywhere. So if you typed in portal.azure.com in China, you'd go there. If you typed it in Turkey, you'd go right there. And again, it's everywhere. So it's all in all the individual data centers to make sure that you don't have a failure and that the portal is always available. The portal updates pretty continuously, so there's no downtime for maintenance activities. So while you can't customize your home page, again, you can do dashboards as a default view. And again, when you're dealing with people and you're dealing with business units, just dropping them into a dashboard when they log in is probably the easiest way of managing user expectations around the cloud and how people will access the data that they need. If you've got developers, you drop them someplace else. But for most of your business units, you drop them into a specific portal, a specific dashboard for their default view, and let them just go from there. There's a neat neat way of just setting this up so that everybody's happy. That's what I really like about the portal. You can literally set this up so that everybody is happy and gets just the data that they need to have to do their job. So the interesting part, though, is your PowerShell is just another set of managing resources. If you've ever done any kind of Windows server administration, you know PowerShell commands are a great way of managing a server. It's a great way of setting up people. It's a great way of managing process and deployment and updates and all the rest of it. It's designed to run commandlets for managing Azure resources directly from PowerShell. So there's a whole separate section in PowerShell just for Azure. And it's designed to make sure that you get started up and easily set up in Azure, and provides a lot of powerful features for automating all your setups and all your other things. You can then turn around and do this as a wrapper module for the Azure service-related PowerShell modules. So essentially, though, you can be tacking into the AZ network or AZ Kubernetes service for Azure. And again, you can just tie all this stuff together nicely as one big PowerShell script, so your managers, your system administrators who are already working in PowerShell are very comfortable moving over to the cloud. Then these commandlets in the Azure PowerShell module make REST calls to the Azure API. And that's the big thing to remember, that if you're in a remote environment, that you're going through some kind of VPN, you're going through some kind of tunneling that's encrypted, because you're going to be logging in and you're going to be doing Azure API REST calls to make things go. So if you do things inside a PowerShell module that are limited to twice a year, you want to make sure that you're not making breaking changes, and it's something that will break along the way. So many breaking changes at the API level are handled within the commandlets to prevent that perception of that breaking change. And that's the big thing. If you break something, you have a way of backing that out, and that's another big part of it. But just make sure that you've got a nice, clean way of accessing it. Azure PowerShell module contains commandlets performing both control plane and data plane. So you can actually manage servers, or you can manage data, which is neat if you're a data analyst and you're used to working in Azure PowerShell to attach to your SQL service. Boom, you're working in the same environment. You can use the control plane to manage your resources, and you can use the data plane to use capacities exposed by your instance, right? So if you have a VM, you can manage your data that way. If you have Kubernetes, if you're working in containers, and again, all that capabilities by your instance and resource type. Now, the weird thing, you must install PowerShell to access it on regular Windows, Linux, and Mac OS, but there's a simple download, so that's not a problem either. Again, the big thing is just making sure that you're tracked back to the Azure data center is actually in a secure tunnel. The Azure command line interface is a little bit different, right? So it's not an actual PowerShell. It's more like your old traditional DOS command line, right? It's just simple execution of commands through a terminal. You can use scripting, command line prompts. It depends on how you want to do it. And this is a little bit more old school. So people that didn't pick up PowerShell will probably pick up command line interface, but you can move between the two. And it just makes things a little bit easier depending on where your system administrators are. So PowerShell, more modern, based on commandlets. CLI is more just based on simple commands that you would use like in any kind of DOS environment or just regular Windows environment that has people using command line interface. And again, you can do things on Bash, Linux, Mac OS, and issue command at the shell prompt. You can do it kind of interactively. You can also use this to automate repetitive tasks just like you would in Azure PowerShell. But you can just go ahead and run it using a shell script with the syntax of your chosen shell, right? So Bash or whatever shell you want to do, command.exe on Windows, depends on what system you're on. And you can install this locally. Again, this is a download for the Azure command line interface, and you can use it through a browser through the Azure Cloud Shell. So you can run it inside a Docker container. There's lots of neat things you can do with that whole process. Cloud Shell is actually really kind of neat, especially if you're not comfortable working at the command line, or you don't have a way of ensuring that the link between your computer and Azure is clean. You can go through Azure Cloud Shell. It's an interactive, authenticated, browser accessible shell. So you can use all the browser security to make sure that you're not exposing your username and password. It's really flexible. You can choose your experience, the best way you work, either Bash or PowerShell or otherwise. Cloud Shell enables that through the browser, right? So that's the big one, right? You can leverage Cloud Shell to work untethered from the local machine, And that's also a neat kind of part of the process. It's just making sure that you have a clean way of getting to the command line in your Azure environment. And Cloud Shell, if you're uncertain, is a really good way of making sure that you've got at least a secure path between your computer and what you're doing in the Azure cloud. So Cloud Shell is managed by Microsoft, so there's a whole bunch of command line tools and language support and everything else that you would expect. Cloud Shell also securely authenticates automatically. So you can go through the Azure CLI or Azure PowerShell commandlets and make sure that you are actually authorized to do the things that you're trying to do. So again, just a neat way of interacting with something if you're not sure of the path, or you just want to just do something really, really quickly in Cloud Shell without having to download software or anything else. These are really dependent upon your work style and how your developers want to work, or how they're comfortable with whatever they're using, whether that's just the old-fashioned command line or using PowerShell to manage systems. So the cool part is they all get to figure it out. There's also some mobile apps that gives enterprise developers and system integrators a way of going through and tapping resources in the Azure cloud with a mobile app. Just about every cloud provider has this, and that mobile app will take care of any of your managed platform as a service offerings, or some SaaS offerings, but basically it provides authentication, data query, offline data synchronization. It's just a way of making sure that you can do things in the app at a limited experience that you would otherwise be able to do in the browser. The app just makes it a little bit easier in that process and gives you a little bit cleaner way of enforcing security and enforcing policies. So everyone provides this a way to go through the app. So if it's 2 o'clock in the morning, you don't have to log into a computer. You can just pick up your phone or your tablet, go through the app service and fix whatever needs to be fixed. It's just another way of accessing your data. You can build a lot of cool stuff with the mobile SDKs though, right? You can build some native and cross-platform apps to help you with your particular app service, right? So you can make little command sets within your app service. You can connect to your enterprise systems, and you can build offline ready apps for data sync later on. Right? So you can really make your mobile workforce a lot more computer literate and a lot more productive by building apps specifically for your company to do specific things. So you could do specific dashboards, you could do specific things inside this app to kind of help make sure that people know where they're at and what they can do with using the app service. It's just a neat way of customizing what your portal is going to look like or what things can do on this. So in summary, there are 3 core command line ways of accessing Azure resources: PowerShell, command line interface, and Cloud Shell. And depending on where your comfort level is, you're either going to be using PowerShell, command line interface, or Cloud Shell, depending on the circumstance, comfort, all the other things that you need to have to make sure that your resources are secure and that username and passwords are not being sent in the clear. You can go to the Azure Portal, and that's your web-based way of accessing all of your Azure services. And Azure Mobile is just a neat way of supporting your mobile devices via the software development kit or command line. You can manage most of your stuff, or you can bring up dashboards. There's just a way of customizing how your company interacts with their Azure resources along the way for a mobile app. It's just a neat thing to do. If you've got really, really good programmers, they can make some really neat things. So your CEO can always have his dashboard and be ready to go wherever they are all the time. So that's essentially all there is to hooking up and connecting to Azure services at the command line or through the portal. And we have a portal walkthrough after this, so definitely stick around for that and take a look at what the portal looks like. Thank you, and I will see you at the portal walkthrough. 3.7, talking about the Azure Advisor. This is kind of a smaller section, so fairly straightforward on what you need to get through for the exam. So the Azure Advisor is essentially your cloud consultant that helps you follow best practices, and that's really all it is. And it helps you optimize your Azure deployments. So basically, it will take a look at everything you're doing and make recommendations to help you improve cost of performance, reliability, and security. So it's a really neat all-in-one dashboard for making sure that you're not wasting money, that you're not exposing your stuff to security risks, that you've got really good performance, or there's specific things that you need to do to come back into conformance, and just basically make sure that everything in your account is secure. So this is a place that you're going to spend a lot of time as a system administrator to make sure that what you've got cooking and make sure that everything you need for your deployment is safe, secure, and functional. So with Advisor, you can get really proactive, actionable information, right? And you can make it personalized to what you're doing. So that's the nice part about this. This is sort of like having a consultant in your back pocket. That's basically an AI going through and taking a look at all your stuff. You can improve all of the performance, security, and reliability, help you identify opportunities to reduce your overall spend, and get recommendations with proposed actions, things that you should specifically do. And that's a really good part of understanding how Advisor works, is that it tells you what you can do and then tells you, here's what you need to do to make that happen. So you're not just stuck with a thing, you could actually have a goal and process on how to fix that specific process. And then you can bring that into your Azure boards and turn it into a project. And again, there's just neat interaction, right? You can access the Advisor through the portal, and that's the easiest way of doing it, mostly because it is very graphical and very interactive. You can locate the Advisor in the navigation menu and basically, or just search for Advisor and it will take you right there. Yeah. And again, the one thing that you want to do too is make sure that you can apply those filters. So if you have a high, low, or medium, you can help set your resources up for what they need to do. So you can apply those filters to display recommendations for specific subscriptions or resource types, and divide it into 5 categories. The 5 categories for Advisor you will probably need to know: reliability. It used to be called high availability, so just be prepared to interchange those words, high availability and reliability. Improve your continuity, your business critical applications. Security, that's an important one. For your security team, you can make them a specialized dashboard just for this. Detect threats and vulnerabilities that might lead to security breaches. Advisor security recommendations are actually really good because this is a really mature process to kind of go through. So if your security folks need their own dashboard, this is the dashboard that they would want to have. Performance, this is going to be more geared towards your business logic, your business units, and your system administration, just to make sure that your applications are running the way they need to run and that they're super quick and customers get to what they need to get to without a problem. Cost, this is going to be more for your financial folks, and that's just to optimize and reduce your overall Azure spending. If you've got resources laying idle that you're paying for, it will tell you which ones they are and make recommendations on turning them off or consolidating or building other things to make sure that you're optimizing your costs and reducing your overall spend by managing and making sure that you are actually using the resources that you're paying money for. And then the one that's for everybody, this is going to be for all your CIOs, CTO, CISOs, operational excellence, to help you achieve all your process and workflow efficiency, right? And that's just basically make sure that everything is following industry or cloud best practices for manageability through deployment. And again, check your Advisor operational excellence recommendations. These are really kind of interesting and what it will give you, because we all try to do things and sometimes we forget that there's a lot of dependencies along the way. And operational excellence will help you find a lot of those dependencies that may have been overlooked or weren't integrated into the final plan just because you didn't know that they existed. Right? So as your Advisor, you can click a category to display all of the recommendations within that category. You can also learn about actions and perform to take advantage of that opportunity or to resolve an issue. You can select the recommended actions. One of the things, though, is make sure that when you're doing these kinds of things, that you're working with your CI/CD, you're working with your DevOps, you're working with some other team to make sure they understand what changes you're making and why, based on what Advisor is telling you. This may be something that you do a weekly stand-up on for Advisor. This may be its own development team, its own Scrum team, with its own Kanban board for this process, right? Especially if you do not intend to take immediate action on a recommendation. You can postpone it, but eventually you do want to come back around to it and make sure that you've taken care of a problem. You may want to triage this as high, medium, and low. And again, you need to go through that whole process. You need to bring this into your program management process. But again, Advisor gives you a basis of understanding of where your risks are, what those risks looks like, and then a set of actions that you can take to fix those risks. So again, it's a neat product. It's a really neat product to have. It's something that, in summary, is a personalized cloud consultant. And it is really neat on what it does and what capabilities that it gives you. There are 5 recommendation areas: reliability, or high availability as it used to be called, security, performance, cost, and operational excellence. It integrates really, really well into Agile and using all of your other DevOps processes. You will probably want to have a separate team just for what Advisor is doing, especially initially as you build out and bring this into your program management process. So again, for the test, just remember that Advisor is just this really nice personalized cloud consultants that covers reliability, security, performance, cost, and operational excellence. So that's it for this section. Definitely do meet me in the next section where we're going to go over some other really cool stuff. Thank you much. I will see you in the next lecture. In 3.8, we're going to talk about Azure Resource Management Templates. So templates are a really neat tool in using to help you manage resources or standardize things. So as part of your Azure Resource Manager, we've learned that infrastructure has really become just this iterative process, right? The division between operations and development has disappeared. We've turned whole processes into what's called CI/CD. So you have pipelines now, you have a unified process that you'll manage your infrastructure, your application code, and everything else all in one box. It's all one thing now, especially in the cloud, especially as you get to cloud native. And this is a real challenge. This is very different than how we programmed for the last 50 years. And that's what kind of makes this an exciting development, is that's a lot more flexible. But you need to understand that just like any kind of other code or anything else you've got in your Azure Resource Manager, you can store this all off in a source repository and version it. When you start getting into networks as code, when you start going into software defined networks, and you start going into other things, anyone on your team can set up a process as long as they have permission to, and deploy environments, deploy systems, deploy code. So the Azure Resource Manager is basically your big key into being able to treat everything as software. It's all code. Everything is code in this. The good part is they give you a template to help you work through that infrastructure as code solutions. So your Azure Resource Manager templates are that big kick into building out a repeatable and templated infrastructure as code process. So the template is basically what's called a JavaScript object notation, a JSON file. It's just like any other JSON file that you'd have, and that's all you need to know, is that it's just a JSON file in this case. The template will use what's called a declarative syntax, which lets you state what you intend to deploy without having to write the sequence of commands. Right. So in the template, you just specialize or specify the resources to deploy and the properties, and then the resource manager takes care of everything else as long as that template is correct in its syntax and that JavaScript file that you have programmed everything correctly so that it doesn't hitch. But that's why we now have that Azure test environment that we can work in, our test labs, right? So advantages to using templates. Oh my God, these things make life so much easier. I mean, seriously. That declarative syntax allows you to create and deploy an entire Azure infrastructure by saying, I want to do X, Y, and Z. It really breaks it down into a really human language understandable process. You can deploy virtual machines, network infrastructure, storage, web, any other resources that you need. You can work with your custom templates. You can work with your custom images. You can work with whatever you need to push a button and go. The good part about the template is that it's repeatable, right? So you can completely update your infrastructure. You can update your systems. You can do all of the things you need to do through your development life cycle and make sure your resources are deployed in a consistent manager. It takes a lot of personality out of it, but makes it rinse, wash, repeatable. And that's really important when you are working in the cloud, is you want to have a very steady, very stable way of deploying things so that they all come into a same state, or that you get the desired state. Rather than developing a bunch of separate templates to represent those updates, you are just working with one file or maybe two. So those templates really do help you consolidate how you deploy your entire infrastructure for that particular service or process, or even your entire company. But that would be a pretty big template if you're doing it for your whole company. So again, advantages to using ARM templates as your resource management templates are the orchestration. So you don't have to worry about what your precedences are, that VMs come up first, or that I have to have this OSS bucket in place, or I'm doing this network attached storage, or I need to have this in place before I have that in place, or I need to run this particular script. You are setting up one script to manage all those dependencies for you under orchestration. You can do parallel deployments, you can do stop wait deployments, so a serial deployment. And again, you can do this however you want to do it, and you can do it at push of a button, one command, launch all, and you're good to go. They're modular. You can break your templates into smaller, more reusable components. So that's a nice thing about this process is you can break things up so it's more logical for you and how you think, right? You can also nest templates inside of other templates, but be careful about nesting. It can really become a spaghetti code really fast by using nesting. So it's easier to just go ahead and have modular files that are very clearly named for very specific steps in the process rather than nesting templates inside of another template, even though you can do it. And again, it's just for sake of being able to understand that code better. And then there are other advantages. You can create any Azure resource, right? And again, this is all going to be done at the command line or through PowerShell or through otherwise. So you won't do this through the portal, right? So you can immediately use any new Azure service and feature in the template. As soon as the resource provider introduces a new resource, you can deploy it. And that's neat. You don't have to wait for tools or modules or anything else. You just push a button and go. It's really extensible, right? You can add PowerShell or Bash scripts. You can do any other kind of deployment script. You can do anything like Chef or Puppet or Ansible or however you work. You can work with an Azure resource management template. It's all there. And that script can be included to an external resource. So you could actually pull something that's in Git or your GitHub or your Azure repository. And then deployment scripts give you the ability to complete the end-to-end environment in a single template. So you can set up from firewall and system load balancer through web service, through database, through customer service. You can just do it all. Templates are really a neat way of just orchestrating and managing your resources. I do recommend testing. You really do want to test the whole template, right? So there's a whole testing scheme that goes along with it. That you can test kit is a PowerShell script. You can just go ahead and download that from GitHub. It's free. It's really good, but it makes it easier for you to develop expertise in using the template language and making sure that you don't blow anything up. Right, because blowing things up on this can be bad. You can preview all of your changes. You can do what if, especially if you have dependencies or you're doing serial rather than parallel, especially if you have a dependency where I need to update or I need to load specific software because I didn't do it as an AMI that's already preloaded. You need to make sure that there are time waits in there so that if there's dependencies downstream from that software load, that those all wait for that load to come up and test it and set up and everything else. So this preview changes really lets you step through, sequence how long it will take to do all the deployment along your template and make sure that any dependencies in your template are covered and that you will either have pause or waits or countdowns or whatever you want to call it. And you can basically break everything into smaller chunks, especially if you do have larger dependencies or you're waiting on something to load along the way. The other good part about that is that they have to pass validation. The resource manager will check the template before starting the deployment to make sure the deployment will succeed. That way you don't end up with something that's like half started or half finished and you've got stuff all over the place and you don't know what's working or what's working and you have to manually go carve this out of the system using the portal to figure out what's running and what's not running. That's an ugly situation, so definitely make sure you use the built-in validation. And then you can also track your deployments. You can get a deployment history and information about the deployment template. And that's another good thing to do, so you can actually give a positive reinforcement back to your managers or others that need to make sure that that template was deployed, that all the parameters were passed in and outputs were taken into account, and that you are good to go for that entire deployment. The one thing to remember though is infrastructure as code services aren't tracked through the portal, so you will need to have a separate output in either PowerShell or at the command line and drop that data to a specific area for people to pick up that whole process. The other thing I really like about ARM templates is that policy is code, right? So we all have policies. We all have either at least privilege policies, or we have to meet regulation standards like PCI DSS, which are local, or we have to meet legal standards like HIPAA with HITRUST, or otherwise you actually get to automate your policy using ARM templates. And so you can set everything up. You can do policy remediation. You can do stuff on non-compliant resources when everything's deployed through the template. And that's a really nice part of making sure that you're meeting all of your auditing requirements by using templates. And policy as code is a brilliant way of managing that process. You also get something called deployment blueprints. And these are kind of provided by Microsoft to meet your regulatory and compliance standards. And these include pre-built templates. You can use these as your start for building your own custom template, but deployment blueprints will help you meet all of your compliance standards depending on what industry you're in and what you need to meet, whether that's local or regulatory or legal. Depends on where you're at. So there's a lot of advantages, just a lot of advantages to using ARM templates. I'm going to highly recommend that if you do this, this is something you seriously check out and work on. It all ties into your CI/CD integration. You can integrate your templates into your whole CI/CD tool set and then automate your orchestration of all your services. Boom, press the button and go. Exportable code. You can actually export this template out and then work on it separately, or you can view the template. And when you're viewing the exported template, it's a great way to learn about the template syntax, how it works. If you've never worked with a declarative syntax before, just reading the template is kind of interesting. As you step through it, you can start picking out what that workflow logic looks like, and that's really handy. You can also author tools. You can author templates with Visual Studio, or just about anything else, really. You can use Notepad if you're really, really comfortable with it. Depends on how old school you are. You can get a whole bunch of neat things, but that addition to Visual Studio Code, you can use Visual Studio. You can probably use other IDEs along the way. So again, templates are just a great way of making sure that you've got everything covered. So there's a good amount of reasons to use templates, right? And then know that templates exist to speed up development and deployment, and that they are JSON documents. That's really what you want to know. But templates really do help you do things from orchestration, policy, infrastructure as code, and all the other things that are really super popular in the cloud right now. And this just makes your life a whole lot easier as a systems administrator or as a developer in helping you manage your deployments or managing your infrastructure. And that's really it for why you want to use ARM templates as your resource manager templates. And I will see you in the next lecture. Thank you. Section 3.9, and we're going to talk about the Azure Monitor. So the Azure Monitor is essentially a service that you can use to maximize the performance and availability of your application service. And that's exactly what it means. It means it monitors everything that's coming in and out. It ties into all the other things that you would be doing in here. And it's basically your dashboard. It's basically everything that you want to collect to analyze and act on your cloud and your on-premise environment, and how your applications are performing, and any log systems and security and compliance and auditing. And it's all here underneath Azure Monitor. So again, the Azure Monitor basically helps you understand how your applications are performing and help you kind of fix issues as they go through. So there's a lot to this, but it's a really simple kind of process from the test viewpoint. You can do just about everything with the Azure Monitor. So that's the big thing to remember. You can detect and diagnose issues. You can correlate infrastructure issues with virtual machine issues and container issues. You can drill into your monitoring data with log analytics for troubleshooting and deep diagnostics of what's going on with your program and your work logic and your customers and how they're working. It would be kind of neat to find out if you could press a button and find out how many customers abandon their shopping carts if you're an e-commerce company. Right? And those are the kind of things that you can monitor. You can support operations at scale with smart alerts and automated actions. So smart alerts, if I need a human, let's contact them via text, via email, or however. But you can also automate some actions along the way, especially if something goes offline. If there's a problem with service health, you can automate a failover. There's a lot of things you can do with business continuity, with disaster recovery, with just service health, with application health, and everything, including budget. Again, Monitor is really your key to all this. You can create visualizations, and again, dashboards and workbooks. Everybody's going to want their own dashboard. So when you get into this and you start working out what kind of data you can actually get to, your dashboard becomes really important for how your company is going to interact with Azure. And then you can collect data for monitored resources using Azure Monitor metrics. The cool part too is you can also turn this into a data mining exercise, right? So you can actually set this up as a big data project. You can set this up as something else to help you train your machine language or your AI models on how your network should function and what is a bad function and what is not a good function, to help you work through how to automate responses to issues. So what kind of data is collected? Just about everything. Right, but it's going to be either metrics or it's going to be logs. Right, so metrics are basically how much CPU are you using, how many read writes are you using onto your disk, or how is your read writes happening on your database. So they're basically how your thing is performing, whatever it is. And it's basically whatever service is it operating within the parameters that you set. The other one that's more interesting is logs, right? So everything will log something, whether that's your virtual switch or whether that's your virtual machine or whether that's your virtual Linux box or your system load balancer or anything else. All those logs can come back to a data lake, all of them. Every single one of them should come back to some kind of storage so you can data mine these things. You can set different sets for properties of each type. You can use a function as a service, parse those logs looking for emergency actions that you can then queue as a message and send to an automated response or to a human, depending on what's going on. And again, this helps you collect events and traces are stored as logs. And your logs are all of your performance data that can be combined for analysis. And you really do want to do that. And this really becomes a really interesting big data lake process for what you're doing here. And it's just a great way of collecting how is everything functioning. And this is a viewpoint that not everyone has ever had before for people who are stuck in their traditional data center that don't have a comprehensive ability to manage or understand or visualize all of the data coming off all of their systems. It's still pretty stovepiped or hierarchical. This removes the barriers to the data. This puts the data in the hands of people that can come in, see what's going on, and kind of see the interactions between systems, network, operations, and code, and really start working on building a more comprehensive and more unifying environment for all of your IT needs. And the Azure Monitor is the way to get started on that. For all the data, for all this is all automatic. Azure resources are going to generate data, and it's your job to just capture them and go right into what you're doing. Your metrics are going to be captured right into your overview page in the Azure Portal. You can get a heads-up display on how everything is working by the metrics, right? You can also make new charts and pin them to the dashboard or view them with other visualizations as you go through the process of setting up how you want your data to look. You're probably going to want to have a data analyst on board when you set all this stuff up to kind of help you out. And again, there's log data. Log data is the really critical part of all this. Besides how your machines are running, what's going on within your machines or what's going on with your code and how your code works, because you can actually debug each step as a function in your code. So your log data, it's all done by Azure Monitor. It can be analyzed with queries. And again, this is your data lake. This is your big data project. You can create and test queries using log analytics in the Azure Portal. If you've never done log analytics, they are fascinating to see what's going on with your systems. Again, this just opens the door to so much neat data that you've probably never seen. So that log data is really important, and you can actually go ahead and use log analytics, but there's also a better way of tying it together with your data lake and custom analytics along the way. But you can save your queries. You can do some rudimentary things with that, do alert rules, use different kind of visualizations, work with a data analyst for this. Your data analyst and you will have a great time fishing through the data to figure out how everything is running and why it's running the way it's running. And that's really the summary on the monitor, right? Your Azure Monitor is everything. It's either metrics, how your systems are performing, how much CPU, disk I/O, read writes, database, what's your overhead looking like in terms of performance, so that you can then go set up summary alerts to start a process. So if you hit 70% on your virtual machine and you want to start a new one, that becomes an actionable alert that can start an automated process to set up a second virtual machine to help you. Your data is either logs or metrics, again, so your metrics, you can set alerts. Your logs, also you can set alerts. Logs are more interesting from that vantage point of understanding what's going on inside your systems and how the data is flowing and where data is moving to and who's coming in to access that data. So all of this stuff makes a really great data lake kind of process for analytics, and you already have a built-in analytics package for your log analyzer. But that's the big one. Monitor is either logs or metrics, and there's a built-in data analyzer. Good stuff. But that's it for this section. Log Monitor is really kind of a short section on this one, but that's really all you need to know. Logs, metrics, and data visualizer, and you're good. It covers everything in your Azure environment. So thank you much. I will see you in the next lecture. 3. So this is section 3.10, Azure Service Health. This is a really small video. There's not a lot to this video in terms of what you need to know, but really what it is service health. is a way for you to create a customizable dashboard that tracks the health of your Azure services. So as we were talking about in section 3.9 with your dashboards and everything else that would go along with your Azure Monitor, service health is specific to the health of your Azure services in the regions where you have them, right? So that's the big difference between the Azure Monitor, is that it's a little bit of everything, but service health is specifically to the health of the Azure services in the regions where you have them. So the service health dashboard, you can view ongoing Azure level issues, upcoming maintenance, relevant health advisories, and it all retains a history of up to 90 days. Service health is really designed to create and manage service health alerts, which will notify you when a service issue arises. So Azure Monitor, your stuff, service health, what's going on with Azure on the global environment. Especially if you have a problem in a region, if a region goes down, service health will alert you that a region is down, and hopefully you've set up some kind of failover that you can move to a different region, or you can move to a different set of the globe, depending on how you've set up your failover and how you've set up your business continuity and disaster recovery. So there are specific types of health events that you need to know about. One of those are service issues, and those are problems in the Azure services that affect you right now. So if you have something going on in a virtual machine on that part of the fabric, those service issues and creating a VM may impact you if you hit a spike. So you should have program logic that if I can't do a thing, I will fail over or move to a different region or start up resources in a different region and do some weighted routing on my DNS. Right? These are things that you can do really easily if there's a problem with the service. There's also planned maintenance. Now, the good part about Azure is that they really do try to make sure that planned maintenance does not affect anything that you're doing. There may be an emergency planned maintenance that can affect the availability of your services in the future. But in general, these are not to impact, but sometimes it's going to happen. The other one that's really nice are the health advisories, changes in health services that require your attention. And those Azure services, we may be turning something off. We may be moving to a different PHP supported framework. We may be turning off this .NET library, something we may be turning off in Azure PowerShell. So all those health advisories, what's coming in, what's going out, those are really important for the dependencies that you use at the code level or at the service level. So you do want to pay attention to those. And then finally, the security advisory. These are probably the more important ones. They should go straight to your security department. And anything that's going on, including violations that may affect the availability of your Azure services, is going to go to you. So if there's an issue with security level, you want to really pay attention to these, because anything that impacts security can impact the integrity and confidentiality and availability of everything you have going on in the cloud. So again, just a really short section on this one, really just more about understanding that Azure Health, those Azure Health services are basically things that impact your resources in Azure's view. All right, and you can understand when the issue began, what services and regions are impacted, and you can also read the most recent updates to learn what Azure is doing to resolve the issue. It's just basically Azure level service health that you need to pay attention to, and security advisories. The biggest one are going to be things that impact your business operations and security. And that's it for this section. This rounds out and closes down all of section 3, which is a big chunk of your test. And definitely take the quiz. Thank you, and I will see you in section 4.